one, you have a little triangle, right? And I label this theta, but the theta is really pi over 6. And then this side's 10 centimeters, this side's x, and I want you to find x. Right? So you're going to use a trig function, right? Which one did you pick? Cosine, so SOHCAHTOA, TOA, if you've heard that before. So cosine of some theta is, the adjacent, the hypotenuse, so that'll be 10 centimeters over x, right? So we can just do 10 centimeters over x, and this theta is pi over 6 radians. Does anyone know what cosine of pi over 6 is? Oh, without a calculator? Root 3 over 2, very good. Very good. So, root 3 over 2 is 10 over x. So, these sort of things, cosine of pi over 6, cosine of pi over 4, cosine of pi over 3, pi over 2, those are like things on the unit circle. Is that ringing a bell for people? Yeah, okay. So, those are really helpful to know, just especially when we get later into the semester. It's good to just maybe refresh those now, because then you'll see them again. So like just have those kind of like, give yourself a refresher now, and then you'll see it again. And then we'll just keep on seeing these radiant things again and again, and it'll kind of stick in there better. So these are just nice, because then you don't have to worry about, oh my gosh, my calculator is like doing weird things, if you just know this, and then you can. So to solve this, we have x on the denominator, so I like to get it up in the numerator part, so I'll multiply by x on both sides. And then I just divide by this coefficient, so you get x equals 20 over root 3. Did I mess that up? Sometimes on the board my arithmetic's terrible, but so you get the idea, right? Okay, so that's number 1. Number 2, how is a vector different than a scalar?
Vector has magnitude and direction, and a scalar is a little number.
Yes, so a vector has 2 pieces to be a vector. You have to have magnitude and direction. A scalar is a lot simpler. You're probably more used to dealing with scalars. It's just the magnitude. So things like how much time, so you could say like, how many apples do you have, right? Like there's no direction, like I have 3 apples. Like it's not like 3 apples north, right? Like that doesn't make sense. Direction, you don't need that. But when you're specifying things like vectors, we'll get that more into that today, and you probably read about it or at least outlined on it, that a vector needs a magnitude and a direction. So this talks about different quantities, things like, where is the Einsteins, right? So like you can't just say like 100 meters, right? And then people are like, okay, but like where, right? So we'll talk about that. And then this last one I put on because of some silly mistakes I saw in the first quiz. So you didn't get a chance to like look at your feedback really from it. So this kind of was unfair if you like made this mistake and then like did it again. But I wanted to put this on there to kind of bring it up and make sure I mentioned it. So I asked how many square centimeters are in a certain amount of square meters, right? And so we talked about converting between units, but some people were a little bit too quick when they were switching between, I think it was feet squared we had for the area, and they were switching to like meters squared, and like it was good and above and beyond, but you missed doing it a second time because you have 2 dimensions, right? You have meters and meters, not just, so I'll write this out. So we have 0.3 meters squared, and I want to change it into centimeters squared. So in order to change the units, I multiply by a 1, right? So I could take 0.3, and here's my units as meters squared, and then I could change between meters and centimeters, so I need to do some sort of, factor of 1, right? So I want to get rid of meters, so I should put that on the bottom, and then centimeters should be on the top, and then how many centimeters are in a meter? 100. Gotcha. Millimeter is 1,000. That's another thing that it's so funny because like even like late into the semester and we've been talking about centimeters, it'll still trip people up that 1,000. So just centimeters is 100, millimeters is 1,000. So we have 100 centimeters in 1 meter. But you'll notice, okay, so you'll notice that meter cancels with meter, but really this is squared, so it's like meter times meter. So I only get to get rid of 1 of them. So then I have a meter times a centimeter, which is not a centimeter squared, right? So I have to do it again. So I multiply by another factor of 1. And now this will cancel out the second one. And then I will have centimeter times centimeter, which is centimeter squared. So when you have squareds, just be careful. You have to do it, enough times to change all of the units. You can't just go halfway and then be like, okay, enough math. So make sure when you have squared or cubed or something like that, that you do that unit change enough times. Otherwise, you might get really bizarre numbers that you're not expecting. So there should be, a factor of 10 to the 4th versus just 10 to the 2nd attached to this thing. All right, so those are those.
Wait, I
And-
have a question about the first one. Okay, so
Yeah.
is it okay if we use our calculators, so we don't have like a clean answer where it's like 20 over the square root of 3?
That's fine.
Okay.
That's fine. So a couple things about your calculator. So it's good to know those nice, even radians. So again, we'll memorize those, even though it seems tedious. Because then you don't have to kind of question, what is my calculator doing? The thing I will warn you about your calculator is that it will give you a certain range of, so depending on whether you're doing sine or cosine, it'll look at just part of the unit circle. So if you're looking at something over here, it might give you the wrong angle. I think for this one, you'll probably end up fine, but I'm not quite sure. But so just be aware and double check that if you use your calculator, if you want to use it, that's fine. But make sure that the answer physically makes sense, right? So if you are expecting your vector to be pointing this way, for example, and you get this, right? So just be aware, kind of draw a little picture for yourself, double check that your answer is right if you're going to use your calculator, right? Because it can just be a little tricky. Good question. And you could double check your answer if you wanted by, kind of plugging out what is the square root of 2 times, or square root of 3 times, whatever it was. Okay. Okay. So today, my iPad is working, which is really exciting. It wasn't working in the morning on Monday, but then